Yes. Hello, everyone. Welcome.
Hello.
Hello.
I'm trying to see my own. There we go. That's it. So this is the second edition of Machine Club. It's the club where we talk about bits and bytes and machine learning and data science with a couple of interesting people from around the world. Our first one, we talked about feature engineering and SQL, and this one is going to function like a real club. I'm even dressed in some club attire. We were going to start dancing soon. No, that's just a little personal joke. But Matthew Yeager is going to present an end-to-end MVP on machine learning platform from Google. A couple of different elements he's going to put together for us. But he's going to be here in a few minutes. So this is like a real club where everybody is kind of shy and we get in the door and we're waiting for the main act to start. So it's a good idea to get to know each other. I think at this point, I know all of you. I know some of you better than others. So it's really cool. I started talking to Gustav. Gustav is somewhere north of London, right, Gustav?
That's right. South Oxfordshire represent.
Excellent.
Very, very west side.
That's excellent. I've had a couple of nice chats with Gustav thus far about life, the universe, everything. Some really good books. He's kind of a really interesting person. You're currently a CTO of Peltarian, right?
Oh, I wish. No, we're a 60-person startup.
Okay.
I effectively own the customer experience. And because it's an area that I don't really know, I'm a cloud and build things for people. Just physics on the wire is where I feel comfortable. In statistics and understanding logistic regressions, I'm way out of my depth. And I find it interesting that I'm now able to use deep learning to solve problems. So it's a journey, and that's why I'm throwing myself into the deep end in places like this. I also run a little data science meetup in Reading, close to where I live.
That's amazing.
In the name of learning.
That's incredible. I think these things are, I think most of them are really very structured sometimes, but I like the ones, and I try to keep this one also like kind of informal. So we have a discussion and we have some formality, like a formal learning, but really it's like a fireside chat, and nobody really has kind of time to go out into the internet and read and see all the courses about data science, and it's mind-blowing what's out there at the moment. I think this kind of forum, we try to be practical and help each other. The things that are really interesting happen when we struggle the most with our day-to-day jobs, and the problems that we solve day to day. So it's really cool that we have these meetups and similar to what you are doing there. So
yeah, actually, my problem of the day. Hello there.
Hello,
Tamir, you just joined us.
Hi, Tamir. Welcome.
The problem, since we are just chatting, I'm trying to figure out what is a good shape for a very generic pipeline. Because if you are in deep learning, it's always going to be #it depends. I'm going to make those T-shirts. Because you want to attack a problem, you can do it with a small Go binary and Bash, or you can do it as a Spark job that has infinite compute. I'm leaning towards some kind of queue, Dockerized worker, and inside there you run anything that you need, a queue out, and then I guess I'm struggling with the pieces that click together. At some point it has to be SQL because everyone lives in SQL.
Yes. Yes.
I would love to hear other people's feedback about things that they have worked with. I know my hard no's are Hadoop. I don't really want to touch Spark, but it's likely that my customers will be in Spark. But so far I'm doing whatever I'm doing in a Jupyter notebook. I might just package that in Docker and run it as a service in Kubernetes and say, the queue does the transform and the queues hold in has been transformed and out. I'd love to hear people's opinion.
Yeah, I have my own opinion, but I would love to hear from other people what you would see. I think the question on the table is what do you see as kind of a out of the box pipeline infrastructure that you can package into Kubernetes? You know, what does that look like from data set living in database X to training a model, which is what we're going to talk about later with Matthew. But I would love to hear if anybody has done this kind of end-to-end packaging of data science, machine learning problems like this.
Specifically also, sorry to interject again, if the data isn't nicely, cleanly pre-computed in an SQL, like in a cell in a spreadsheet, if it's a video and you are ripping out every 20th frame, and in that frame you're doing image segmentation to highlight the person in a frame or the car in the frame. So I can do the latter, I can do the segmentation, but I'm looking for efficient ways rather than just hacking forward in a Jupyter Notebook until I've created a data set. Ideally, like if somebody then says, after you've hacked for 3 days, like do this again, but it's 1 million images and you need to be done by lunch. Like, okay, what's the thing that I suddenly scale to 1 million?
Yeah. Well, if anybody has a thought on this before I give my thoughts? What about you, Bernard? Are you involved in these things? So Bernard Dievenhofer is also on the call.
So I've looked at a lot of Google Dataflow architectures. I haven't actually used any in production, but that's probably the route I would go. That scales well and integrates with all of their Cloud SQL services. If you want a SQL database, if you want a NoSQL database, you can do that.
Yeah.
So if you haven't looked at that, I would definitely say investigate that as well.
Yeah, I think Dataflow is, Gustav is very familiar with that, I believe. I think it's part of his background. So I want to add to that. I think currently I'm with SuperQuery, and we do SQL. It's kind of, if you think of second thoughts, like when you think about thinking, so we SQL about SQL. That's the best way I can describe it. We've got a couple of billion SQL queries living in the database, just the text of, the syntax. And this kind of problem, I say our first question always is, can we solve it with SQL? Like, how far can you go? Because you're sitting with a supercomputer, really. If you use something like Google BigQuery or I don't know, one of the other technologies like Redshift, you're really sitting with a bunch of computers capable of aggregating data for you with just a very capable, efficient query. So I would start doing some processing with the SQL itself, just by seeing how far I can push Google BigQuery, for example. I mean, if you look at the functions that it has, things that we use a lot, it's got all of you can do complete regex on anything, right? You can build custom functions where you extract using JavaScript inside the SQL. You can use JavaScript to calculate something across a field. So already you're using the supercomputer to look into your data and process, kind of transform, and then push out to the other side. So I find this fascinating that you have this machine with all these functions and calculations that you can do without even touching any technology beyond that. Right. So this is hello, Matthew.
Hi.
Hi. We have a couple of these are my thoughts. Gustav, let's just wrap up this point. I think we can talk a lot about it, but does that kind of feed into your answer for now?
Oh, you're asking me? Yes.
Yeah.
I love the Google set of tools. Many of the customers that I work with just instinctively say, "Oh, this isn't leaving my data center," and then I want to be able to say, "Well, just put this stuff in a box." So that's often why I'm defaulting to things that are can be managed with pandas, or like as a data frame or as a SQL query from some kind of SQL source. You jibble it around.
Yes.
If you've done image transforms, you take the image ID wherever it is, S3 or a bucket or NFS.
Yes.
You take that URL or the URI in a table, and then you're done with the data set.
Yeah,
as much in SQL.
Absolutely. I mean, my suspicion is you wanted a bit more sophisticated answer, I guess, because there's a lot of things. We're talking about Kubernetes and packaging something end to end that you can deploy, scale, and then just run. And it takes in your data from somewhere, does its thing, and puts it somewhere else. This is the kind of.
No, but I hear you. If you can't with SQL, you're saying try with SQL.
Yeah,
try your hardest with SQL.
I think you can go really far. Cool.
Thank you.
Thanks for that, Gustav. So we have Matthew Yeager. Hi, Matthew. Welcome. You're sitting in Google's offices in London, right?
I am indeed. Yeah.
Incredible. And one of the 1 million small cubicalized. Is that if that's even a word? Little meeting rooms there.
A gajillion, I think, is the official term.
Or a Google, right? Or is that the gajillion?
Yeah, you can go for a Google, a gaggle, a gajillion. Yep, all of those work. Incredible.
Matthew, so we were just introducing each other. The people in here, I just want to introduce you to them. If I look at my list here, we've got Gustav Moskowitz, which you know really well. With Beltarian. We've got Alina Zhang from Toronto working with me. We also have Tamir Klein working with me in this meeting. We have Bernard Dievenage, which is an old friend of mine. He's moving to Canada, I believe. He's also deeply into data science. We've got Daniel van Niekerk, currently with Takealot, which is the Amazon of South Africa. He's in this group. We've got Laurens Olivier. Laurens, if you remind me where you are currently working, I forgot the company's name.
It's quite a small consulting company called OnPro.
Cool.
So we try and get involved in data science, digitalization, transformation type of projects.
Yeah, you do large-scale projects with industrial clients, I think, in the industry, heavy industry things.
Yeah, some. We do a bit of predictive maintenance type of work. We do also work in the banking sector and so on.
Excellent. Brilliant. Thank you, Lawrence. Appreciate it. And then Matthew Jackson, I haven't met you formally. Who are you? What are you currently doing again?
Hey, so I know Matthew from MetaFused, so he's invited me here, but now work for a startup in Manchester called Netasia. So in short story, we do real-time machine learning, analyzing web traffic for bots, basically.
Brilliant. Cool. And then, so this is the right place for you, a meeting of the minds.
Hopefully.
Oh, welcome. Welcome very much here. And Tamir Klein, he's the CTO of SuperQuery. Very, very good to have him here to talk with us and brainstorm and have a nice chat. So Matthew, we're talking on Google and MVPs and everything else.
Yeah.
The floor is yours. I think what we'll do is you'll lead the discussion from here, and then afterwards we'll have our fireside chat about these things and talk to each other about who's been involved in parts of this before and how we find it and take it from that point.
Okay. I can present with this, right?
Absolutely.
Says the guy who works for Google. Currently using Hangouts. I could use the excuse it's not in my product family, but that wouldn't be very googly, I suppose. Yeah. Look, a few ground rules. I'm not sure what the discussion was kind of coming in. I came in on the kind of tail end of Gustav, of Gus, and you having a chat. Look, a couple things before we get started. I work for Google, but I really don't want this to be construed as a rah, isn't Google great? You should use Google, because
Yeah.
Nothing could be further from the truth. It happens to be who I work for. I also happen to use GCP quite heavily, but I really wanted to talk today about why I use GCP heavily. And I guess if there's anybody on the call that has like a shed load of resources, and I mean physical people, then I'm going to apologize to you now, because this is probably not the talk for you. So I wanted to talk about how do you use limited time, finite time, and finite resources to build MVPs in machine learning projects. Now, the other kind of big caveat is that I'm going to talk, the stuff that I'm going to show you in Dataflow and some of the other bits that I'll show you. Look, it's continuous and contiguous data. There's no vision data in here. And so, again, what I don't want people walking away from is thinking that I've showed you the golden path to, data management nirvana. I think one of the things that as an industry we suffer from sometimes is thinking that there's only one way to do things, and there's just not. I think there's multiple relevant ways to do something, and really it's using the right tool for the right job. So I've kind of built a career on I guess building Swiss Army knives, if you'll pardon the expression. I am a certified or certifiable, depending upon who you ask, but I am a certified data engineer. I'm a certified data scientist, if that means anything. I guess we could even argue over what the definition of a data scientist is, but I wanted to attack kind of what I'm going to talk about around managing data and getting data ready for models from the perspective of a startup. Now, before I go any further, is there anybody kind of not in startups? Is there anybody on the call that works in a big enterprise?
I guess Daniel is still in a big enterprise, but pretty soon not anymore.
Okay. Then look, I'll try and stay on the call as long as I can without getting kicked out of the room that I'm currently in, to answer any questions. But the thing that I would always say to someone who is in a big enterprise, even though I'm going to use some startup terminology, I feel pretty strongly that some of the tools and some of the methodologies that we've developed in startups are every bit as applicable in big enterprises. And indeed, I've worked in big enterprises like EMC, previously. So I'm using it as a wrapper to kind of get us started, but I don't want anybody walking away thinking, three things: that A, rah must use Google to do this. Not true. B, rah startups, I should work in a startup. Look, the two toughest things I've ever done, don't tell my wife this, by the way, because I'm not including childbirth and marriage in this, but the two most difficult things I've ever done is A, be in a startup, and B, data science. Absolutely the two most difficult things. So really what I wanted to talk about was, let me see, how do I view more apps? No, present. Okay. So if I screen share, I'm sharing like my whole thing now, am I?
Yes, you are.
Hey?
I can
Okay.
see myself. It's incredible.
All right. Okay. So this was what I wanted to talk about. So if I say MVP, does everybody understand what I'm talking about?
Minimum viable product.
Yeah. So really what I wanted to talk about was MVP to SRE. So that's site reliability engineering. So in essence, how would you go from nothing to an MVP and then operationalize that? And we're using that in the context of GCP, but you could easily kind of replace GCP with just about, I know Gus was talking pandas, so I'm happy to talk about how you would replace some of the stuff that I'm going to talk about with pandas data frame and other bits as well. Okay, is everybody okay with that so far?
Yeah, it's perfect from my side.
Okay. So look, if you look at any public cloud architecture, I'm going to throw stones at Google because I can. There's a shed load of stuff in there. So if I was going to sit down and build an MVP or build product or build a model, I'm not even entirely certain where I would start. So, and by the way, this isn't even all the products that are available via the Google Cloud Platform. So there's just like a shed load of stuff. So I feel pretty strongly that, you know, if you're in a startup or if you're in an enterprise, you can for sure throw machine learning at things. You can do things for the pursuit of it intellectually. But really, ultimately, if you're building anything, if you know, are not building something that people want, it really doesn't matter how elegant your model is and how great your data is. You're not going to kind of go very far. The other thing that I feel pretty strongly about is we're talking about tools today, but we could also have like a separate conversation around the timing with inside startups and with inside enterprises about what it means to have the right people on the team and then also pick the right market. Because sometimes you might have the right idea for a machine learning model, you might have the right idea for, quote, applied AI, but you're either in or working with the wrong team or indeed working in the wrong market or both, right? Okay, this is one of my favorites. I share this with people kind of internally, but these are the three problems that I commonly see with inside startups. My job with inside Google is to work directly with startups to help them build whatever it is that they're trying to build across many and several different verticals. And by and large, you can kind of put them into three different buckets. They generally either have a challenge with scaling, they've found product market fit, and now they need to figure out how to scale that out. They've got a culture problem where maybe they don't have the right processes, or they're not moving fast enough. They're still using maybe sprints that are 2 or 3 weeks long when really they should be 2 or 3 days. Or the third, and probably the biggest, and it's the one that we're going to talk about right now, is they don't actually know how to take all of the brain power that they have and build it into an MVP that's meaningful for their customers. Okay, so we're going to, if people are okay with this, we're going to use a fictitious example. We're going to call it KIPCO. And KIPCO was started today. And Kip has decided that he's big into AI and big into machine learning. And really what he wants to do is he wants to sell applied AI to anybody that wants to buy it. He's also been reading about, has anybody read about wide and deep models? So if I kind of stop here, does this look common to people? So if I talk about deep and wide models or wide and deep models, people generally know what I'm talking about?
Yeah, no, it's fine.
Yeah.
I work in deep learning, and I know this because you told me about it. Usually people go multi-layer perceptron, the end. So no, I wouldn't assume this is general knowledge.
Okay, cool. Well, look, there's many and several different ways to solve a problem. I heard Eben talking about SQL queries. So again, that's probably a separate conversation that we could have, where kind of one of my mental tricks is always to ask myself, if I'm looking at whatever it is I'm trying to solve, can it be solved with a really well crafted and executed SQL query? Do I really need to build a model first? If I've convinced myself that, you know, with data, by the way, that I do need to build a model, then we need to start to talk about what kind of a model, CNN, RNN, LSTM, etc. I'm using this again as a fictitious example, but the founder of KIPCO read about a wide and deep model and how I'll send out notes, by the way, after the call. There's a really good Google Brain write-up on why we use this with inside Google. But in essence, you can do classification and you can do prediction with wide and deep models using basically combining, it's basically an ensemble model by combining a bag of words and embeddings in a way that you can't really do on its own. And when you put them together, some really interesting things kind of happen. I do have a collab that I've got open that I'll show you so that you can actually see this kind of working. But the problem that we have, because Eben wanted me to talk about data pipelines and data flow and so on. So I thought this would be a great opportunity to talk about what happens when a founder has read a white paper and then on the first team call realizes that implementing the wide and deep model that they've read about as a white paper is not only pretty complicated, it gets progressively more complicated when you've actually got no data. So what I would postulate is that when you have a paucity of data, there's a couple ways that you can actually overcome that. But one of the ways to overcome it that I found kind of works is finding data in a parallel vertical. So in this particular instance, let's say that Kip was looking to use a wide and deep model, an artisanal, finely crafted artisanal AI in insurance markets, and then finds out that actually the data to arbitrage insurance isn't publicly available. So now what do you do? Well, if you're looking to just prove the concept or prove the model, there is another way to construct an MVP. And it just means sometimes thinking out of the box. In this particular circumstance, we're actually going to use wine. We're going to use the description, we're going to use the price, and we're going to use the variety and nothing more. So that's a bit, from a wide and deep model perspective, that's a bit of a party trick, right? Because what we're trying to prove is that by using this wide and deep model, that we can predict the cost of the wine, and I don't need to know the name of the winery. So it doesn't matter if it's Chateau Latour or, I don't know, Eben, name a famous South African wine.
Drostehof.
Yeah, exactly.
Okay.
Namakwa box.
Or even Spear, which is a big one here. Yeah.
So one of the party tricks that I do, one of the party tricks that I do with folks here in London is when they're in a different vertical, whether it's insurance, banking, shipping, this works with just about any vertical you can think about where there might be some arbitrage. Being able to say, if I could predict the price of a wine and you didn't know who wrote the description, you don't know how well versed in wine they are, you don't know if they're male, female, you don't know the age, you don't know the winery name, would you listen to me? And 9 chances out of 10, it's a good marker when you're talking to people internally. If you're in an enterprise or if you're talking with a customer and you're in a startup, if you kind of set the scene with that and then they say, no, I'm not interested, or they get a bit shirty with you, you might want to rethink whether building a model is such a great idea in the first place. Are you working in the right market with the right people? But let's assume that they've said, yeah, that's great. Now, the next problem that we're going to have is actually creating or finding the data. Now, I know, Eben, that I said that I was going to create an MVP in 45 minutes. You're going to have to spot me a few bits, because if I built this literally from scratch, it's going to take a lot longer than 45 minutes. But what I thought we could do is, you wanted me to talk about data flow. I'll show you actually training the model, and then at the end delivering the actual predictions, so you can see that this isn't just smoke and mirrors. But I wanted to spend the majority of my time on the data itself. So data flow. Has anybody heard of data flow before I go any further? Besides Gus?
Yeah. Alina's used it extensively before.
Oh, she has. Okay. So look, data flow, ultimately, the reason that I advocate a lot of folks using or thinking about using data flow, ultimately it's actually built, data flow is the managed service inside Google Cloud Platform. What you're actually using is you're submitting jobs via an open source library called Apache Beam. And the idea is that it really doesn't matter if I've got batch data or streaming data. So if I've got static data, in other words, or I've got streaming data, the job that I write, once I've got my recipe and I've got what I want to do to the data down, being able to kind of switch from batch to streaming very often is a pretty quick switch in code. Sometimes it's less than kind of 3 lines. But also, if we think about it kind of in the terms of the wine, think about it this way. What we could do is we can harvest the wine data that we're looking for, create a labeled data set, and then, how do we know that that data set is going to remain consistent? It's not a bet that I would necessarily want to make. And so you could say, right, well, I'm going to harvest, and in our model, we've harvested something upwards of about 1.2 million bottles of wine from around the world, but they were harvested in a static format. They haven't, they weren't harvested in a streaming format, but there's no reason why we couldn't do that. So in other words, if a Pinot Noir from Stellenbosch today sells for $14.99 and has N description, there's nothing to say that 6 months down the road it's going to be worth more, and you'd kind of want to account for that. Well, Dataflow allows you to create that automated pipeline so that you can start to look at streaming data. Could be streaming data that is automated using something like PubSub. It could be batched, and then you're calling it every 6 hours, 10 hours, 12 hours, 24, kind of whatever makes sense for you as a startup or as an enterprise. But ultimately, what you're doing is, and this is really kind of the point that I'm trying to make, with Cloud Dataflow and Apache Beam. And by the way, there's no reason why you can't run Apache Beam on other architectures. We're just talking about Cloud Dataflow just now, but if you've got Spark, you can actually use Spark as a runner in your Apache Beam job. It just happens that right now we're using Dataflow for our example. But what Dataflow is actually doing is it's figuring out what things need to be joined, what things need to be separated, distributed, and then auto-scaled. So it's basically handling all of the DevOps for you.
Where are you getting the wine information from?
We're harvesting it.
In what way are you doing that?
Do you want the real answer, or do you want the club answer?
Is that where the rest of the 45 minutes goes to? The supposed 45.
So there's a couple ways to do that. There are publicly available data sets, but they are from wine magazines. Now, one of the things that I said was there's the potential for bias to be, without realizing you're doing it, to introduce bias into your model by simply using a data set from Wine Magazine in California. Why? Because you might have 300,000 bottles from California, but the way that Californians or even Americans describe wine is likely to be different, to even in subtle differences, to the way that we would describe wine in the UK, in South Africa, in Australia, etc. So the unofficial, I don't know, how wide does this recording go, Eben?
I guess out to the world.
Out to the world? Okay. Well, how do I put this? If you harvested wine from 27,000 wine merchants in a way that didn't crash their web servers, and I think pretty much everybody on this call, I'm guessing, has probably had to do this at one point or another as a data scientist. Harvest
intelligent scraping.
If you said it, yeah. That's one way you could do it, Eben, sure.
Definitely one way to do it.
Absolutely one way to do it. Another way to do it might be you could create your own distributed scraping system so that instead of scraping from one meaty server in one IP block, maybe you've got 17 spread around the world. For example, I don't know. I'm just spitballing here.
Excellent. Cool.
Okay, so for those that have already used Dataflow, this is probably a bit of a boring slide. But in essence, what you're trying to do is you're trying to create an automated pipeline, like I said, that handles, it doesn't really care if it's batch or it's stream. Now, again, the logo or the icon that you currently see there in the middle says Cloud Dataflow, but there's zero reason why you couldn't create the exact same job in Apache Beam, and then use Spark if you have a Spark cluster as your runner. I have to admit, I don't know, maybe Gus does. I don't profess to know what the runners would be from AWS or Azure, but I see no reason if they've got, like managed Spark type services. I'm thinking, is it Databricks? Those are the guys, aren't they? I think they run on Azure. So Databricks, I think, is a managed service for Spark. There's no reason why you couldn't run your Apache Beam job using Databricks on Azure. So again, this isn't a pitch for Dataflow. Okay, I think we've kind of talked about this a bit, but this is the managed service element of it. So when you submit your job, there's two SDKs for Dataflow and for Apache Beam, two primary. The one of them is Python, and the other is Java. Now, of the two, Java is probably the more robust, I would say, for reasons that I'm still not entirely sure of, other than to say I know that's where the code base originally started. The Python SDK is kind of quickly catching up, but there are still certainly things. If you're a Java programmer, if you're a Java coder, then you're certainly one leg up on the rest of us. But in essence, what you're doing is you're creating a job, and then you're allowing Dataflow as a managed service to figure out using graph optimization how it should be joining things, how it should be auto-scaling things, how it should be balancing and then rebalancing both when it's submitted and then during the job. What I would say, again, is a bit of a party trick. Some of the stuff that I'm about to show you, I'm not going to write Java live because that's just suicide. I'm going to use data prep to show you how you could do a job graphically and then submit it to Dataflow. So the modality is no different than physically writing the code. I'm just going to use a GUI to kind of shorten it so that we can get through the call. But again, one of the party tricks that I do is with Dataflow, it really doesn't matter when I submit my job if it's a couple hundred lines, a couple million lines, or hundreds of millions of lines. Generally speaking, my jobs finish in about 17 minutes. Anywhere from the shortest I've ever seen is about 9 minutes. The longest I've seen is about 22 minutes. So if you think about that, you're doing multiple processing. So going back to managing data in pandas, there's zero reason why you can't manage data in pandas. Absolutely acceptable. Writing the Python, etc. But one of the things that I found was when you are doing that, let's say that what I'm about to show you, I'm going to show you about, let's see, 1, 2, 3, 4, 5, 6. There's about 8 things that I'm going to do to the data quickly, graphically, and then I'm going to submit it. That once I've submitted it, it doesn't matter if the data for the wine would be a couple thousand rows or several million rows. What Dataflow does is it auto-scales that so that it's going to complete within a reasonable window. If I've got pandas or if I'm using Python on its own, again, there's no reason why you can't do that. You just need to make sure that you've got a big meaty something underneath you to be able to process that. So whether you're using an S3 instance, if you've got a big meaty laptop or whatever, it's just kind of managing expectations, I guess. I don't want people walking away thinking the answer is Apache Beam, and then whatever I throw at it, it'll handle it. That's half of the answer. The other half is making sure that you've got a runner underneath you that can auto-scale the Apache Beam job. Is that okay?
But we all came here to watch the live Java demonstration.
Well, I hate to disappoint you. I don't remember ever committing to live Java, but I did commit to a live demo. How about that?
Excellent.
All right. So look, there is some proprietary stuff from a managed service going on underneath the covers. I mean, look, I don't think it's, I don't know. Never tell the product teams that I said this, but I mean, it's graph optimization. So how do I put this? It's not that I don't think that this is sexy. I think mathematically it is sexy, but as a data scientist, as somebody who's been in startups and enterprises, I kind of want to spend as much time as I can solving the problem, not managing infrastructure. So I'm quite certain that somebody could write their own thing to do graph optimization, to even do, auto scaling. But I'm not sure that that's time that I want to be spending it. That I want to be devoting to doing that discrete thing. The number that I hear in data science a lot is 80%. Hey, 80% of whatever you're going to do in your model is going to be around collecting the data, cleaning the data, joining the data, doing something to the data. Okay, I'm not going to argue percentages with people. What I would say, though, is you need to kind of ask yourself the question, if I'm spending 80% doing something, am I spending 3 weeks to do 80%, or could I knock that down to 3 days or 3 hours or even less than that? That's kind of how my brain works. And that's why I tend to use kind of Cloud Dataflow and data prep and things like that in the first instance as much as I can. Okay, rebalancing, auto scaling. Sorry, some of these slides, you're right, Eben, you did catch me out. Some of these slides are not mine, and I did borrow them from someone else. But like I say, I'll send them out to you, Eben, if you want to send them to the team afterwards, and it shows you kind of how the auto scaling works in blocks and graph optimization, etc. But if it's okay with everybody else, I'm going to kind of jet past that a little. And then there's your stack. So like I said, you do have Dataflow, but there's no reason why you can't use other managed services underneath. I'm going to plead ignorance here. Does anybody know what that multicolored squirrel is?
Yeah, that's Apache Flink.
Yeah. Okay. Right. Well, I now feel better because now I've learned something as well. So you've got Dataflow, Spark, Apache Flink, but there you go. Really, I think the thing that holds it all together, for me anyway, is Apache Beam. Okay. And then if you wanted to see a code sample, so I didn't write this, Eben, but that's kind of what a sample, that's what some sample code would look like if you wanted to write this thing from scratch. So that is where we're reading from a text file that you're specifying in the command line. You're going to apply the count words transformation. And yeah, not really too complicated. We're going to count the words. We're going to format the counts, and then we're going to write the counts to a file. Again, on the command line.
It's an entire ETL process in one function.
Pretty much, yeah, exactly right.
Pretty elegant.
Yeah. So, like I said, if I was going to spend, if I was a data scientist, stroke data engineer, and I was going to spend any time learning anything about managing the data, for sure, if you don't know pandas, definitely need to know that because, yeah, it's just vital. There's no reason why you can't write SQL queries. You certainly can do that in BigQuery. And then you can port the data, you can port the outcome of that query to a data frame, a pandas data frame, and then do your training. But if you've kind of, for me, that feels like that's where I'm just trying to prove a point, or rather, I'm trying to prove an experiment quickly. If I want to build something that's going to be more robust and more scalable, for me, it would be learning Apache Beam. But that's a personal opinion. I'm not saying it's right, it's wrong. That's just kind of where I land.
It was really impressive. I think it's really cool to see an end-to-end demo in just an hour. So let's open it up, if you will, Matthew.
Can I have a question? Yeah. Matthew, typically I work with Iban, for quite like a few months, and it's always for me a challenge since I'm not a data science in my background. So all the time when working with the data science, they always want resource and data. It's like a junkie. It doesn't have enough data, so it's never enough. So like in the demo that you've done, you said, okay, I'm going to run a simulation, and don't worry about the underlying, something going to happen. So someone who is responsible about the cost, typically when someone tell me not to worry, I start to worry because in the end, someone is going to pay the bill. Now, for example, Google BigQuery has an excellent feature called dry run. So before you run a query, you can actually know what's going to cost you. Is such a concept of a dry run can be applied in other places of, data pipeline and data learning? Because as you just show us, will I know how much money I'm going to pay if I do it with Amazon, if I do it with Google, if I do it with GPU? Something that can help me understand not just, the time perspective.
So that's a really good question. Hold on 1 second. I think I've got it in another, if you'll pardon me for 2 seconds, I think I've got it in another Chrome instance, and I just need to grab the URL. There is a benchmark tool by Stanford that shows you exactly how long it takes. Here we go. Stanford Dawn Deep Learning Benchmark. So let me grab this. Hold on. Okay, let's see.
Is this benchmark specifically for time to finish in terms of learning, or is it for cost, or what is the benchmark for?
All right, hang on. Let's just talk it through real quick. I'll share everything so you don't think I'm making this up. All right, can you see my screen?
Yeah.
Okay, so what we all do is people that aren't data scientists. So I apologize, Tamir, but ask Eben after the call what ResNet 50 is. But in essence, what we do is we take industry-known data sets that have been used for quite some time, and then they're submitted to Stanford, and then these folks actually look at, so you can see the time to 93% accuracy, and you can see how long it took them, and you can also see the hardware that it took for them to get there, right? Okay. So if you wanted to, and the framework, are they using TensorFlow, or they might be using PyTorch, which is from Facebook, PyTorch, MXNet, et cetera, et cetera. So yeah, I mean, look, as a data person, irrespective of me working at Google, for me, I believe as much data as I can get my hands on, the more robust a data set I have, in my experience, the better my results are going to be. However, I totally get where someone would turn around and say, well, what's it going to cost me to do that? So one of the things that we do inside Google is we say, well, we know exactly how big ResNet 50 is. We publish exactly how much it costs to run on TPUs internally. But just, for you guys, because we like you, we'll show you exactly what it costs us to do. So if you wanted to run, if you wanted to train ResNet 50 end-to-end using TPUs, which, by the way, TPUs are the most expensive architecture we have. They were specially designed for machine learning. So there's no reason why you couldn't use a GPU or a CPU. But let's say that you did want to run a data set that was similar in size to ResNet 50 and you run it on a TPU, you can see what hardware we used to get there, and you would see that it costs you $12.60. So really, I think from a business perspective, it all comes down.
Can I ask you this, Matthew? So will it make sense if, like, Stanford has so much information about data model that they're running? Will it make sense to build on top of it a AI or machine learning application which doesn't need to calculate, but learning from the information that you're just showing on this website will be able to answer my question without posting something to Stanford? Is that something that can be possibly done?
I don't understand the question.
So what I see here that Stanford, for example, like the wine example that you did, yes, people send their, a lot of example and they produce a result. Is it possible without running all this calculation just to have a machine learning model or something like that that will produce the answer?
Well, there is, or alternatively, without me being too churlish, you would just look at your GCP billing.
Yeah, what I want to know it before I run it.
Well, I mean, being able to understand how big the data set is and then calculating the approximation of what it's going to cost is absolutely something that can be done. I guess I go back to, without wishing to be difficult, I go back to where the conversation started with Eben and the club at the very beginning of the call. I don't build machine learning models if I can do a really good SQL query. So what you just described is frankly something that I would put into a Google Sheet. I know how big my data set is. I know what it costs per second or whatever. I've got a rough approximation of how long it's going to take me. And yeah, I would approximate it from there. I would say what I just showed you is going to be calculable in the it wouldn't even amount to entire US cents, if that makes sense. So I wasn't using a GPU or a TPU. What I just showed you, you would run in fractions of a US cent. So you can calculate it, but for me, it's not something that we've built a machine learning model about, because we're not entirely sure what people are wanting to use our tools for. And I also don't want to lock you into that either.
Yeah.
I mean, the frameworks that I use were all open source.
It's a fair question. Tamir, thanks for asking it. I think we can discuss with each other after the hangout a little bit more about this. It's a very interesting idea. I just want to open the floor for one more question before we finish. Anybody else have some thoughts on this pipeline and what it means to them? I mean, some people probably have seen it many times. Some people might not have seen it before. Any thoughts from the floor? Anybody has got something on their mind about the presentation?
Well, I would be interested to know what the Keras model layout looks a little bit more. I think you just loaded the model, but exactly sort of the layers you've got in there, I'd be interested to know about that.
Sure.
Is this something we can see in the shared Jupyter notebook, or is it more low level?
Nope. I can happily share it with you after this. There's some pre-processing. The label encoder is actually used. We're using sklearn for that to do some of the pre-processing. And then yeah, there's no reason why we can't share the Keras layers with you.
Okay, is that feasible, Lawrence? We'll send it as a package and all the other links and resources after the call.
Okay, yeah, no, great. I just saw on the that you just loaded the model, but yeah, I didn't see how it was constructed. So I'd just be interested in that. That would be great.
Sounds excellent.
Yeah, no problem.
Just add that on Azure, the Databricks that Matthew mentioned, I think it is also quite expensive. So it's bill shock is also sometimes a bit of an issue that we've experienced. So just to latch on a bit on what Tamir said.
So I'm not trying to be difficult. I'm not sure that I understand. What does ball shock mean?
Bill shock, sorry. So you just spin up the cluster and see what comes out, and you've maybe spent a couple $1,000 to do a bit of a test.
Oh, I see. Yeah, look, I mean,
bill shock.
Really,
bill shock.
Bill shock. Okay, got it. Yeah, look, I can't speak to Azure and AWS specifically. What I can say is that, speaking personally, I have been personally responsible for $4,000 for training, but interestingly, it wasn't on the data that I was training. I spun up a TPU pod. So I wanted to test some ResNet 50. I wanted to benchmark some of the stuff that I was seeing in Stanford. So I decided to go ahead and spin up a TPU pod. Now, anybody that's used GCP knows that if we see a virtual machine that's been online but not used for more than 4 hours, we spin it down for you, right? Unless you've specifically told us not to from the management console or from API or whatever. Anyway, I spun up a TPU pod. I did all of my training, etc. I have to be honest, I didn't think to turn down the pod. And this happened on a Friday mid-afternoon. Went home for the weekend, came back on the Monday, opened up my billing, and there was $4,000 that I'd blown through. Now, thankfully, I was still using credits, but even still, it was 4,000 that went down the Swanee because, not because I was training anything, because I just simply forgot to turn down TPU pod, and I didn't know that we kept TPU pods operable until you physically turn them down. We don't turn them off because we think we might be waiting for data input. There might be data shuffling problems, whatever. So we don't want to turn it down. So I guess the point that I'm trying to express around bill shock is sometimes that bill shock happens not just because of data or because of something that you set up. Sometimes it also happens as a direct result of human error from DevOps and things like that.
Yeah, that's definitely true, Matthew. I would like to thank you, and we can stop here. But if there's any more thoughts, everybody, you have the email address of each person in this call, and you can just reach out to anybody. Reach out to Matthew or to me. I think it was fantastic to see you all here. I'm going to send out the after party email with some resources. Matthew, I'll chat to you on what we can put together to make it sensible. And then maybe the next edition of Machine Club could be about prediction of billing, which seems to be a problem that's kind of universal. And a couple of people are trying to do that, and it's really needed by everybody. So maybe that could be an interesting topic for us to discuss on the next Hangout.
Could be awesome.
All the best for you guys in your work. If there's anything you want to know, just reach out. And thanks for joining the second edition of Machine Club. All the best for you.
Thank you.
Thanks, Matt.
Bye.
Thank you, everyone.
Bye bye.